Hello class, and welcome to the first of our videos about special triangles. The first special triangle we are going to discuss is 45, 45, 90 triangles. There are two types of special triangles, and 45, 45, 90 triangles, I think maybe the more simple of the two. It is a triangle whose angles measure 45, 45, and 90, hence the name 45, 45, 90 triangles. It is isosceles. Since two angles are the same, two sides are the same. It's an isosceles right triangle. This triangle has very special properties associated with its sides. Now, because it's a right triangle, we can always apply the Pythagorean theorem. So let's say that we start here. If I know these two sides are 1 and I want to find the hypotenuse, I would use Pythagorean theorem, 1 squared plus 1 squared equals c squared. 1 squared plus 1 squared is 2. So c is the square root of 2. Let's try another one. How about the sides measure 2 and 2? And you're going to go for the hypotenuse. 2 squared plus 2 squared equals c squared. So 2 squared plus 2 squared, that's 4 plus 4, which is 8. And then you get the square root of 8 for c. Now, you're going to be a good math student, and you are always going to reduce your radicals. Let me repeat that. You will always reduce your radicals and rationalize your denominators and all that fun stuff. So that's 2 root 2. Let's do another one. How about this time we say 3? So if I have 3 squared plus 3 squared, 3 plus 3, or 3 squared is 9. 9 plus 9 is 18. So the square root of 18 is c. Again, reduce your radicals. Perfect square that goes into 18 is 9. So it's 3 root 2. Are you noticing a pattern yet? When the leg was 1, the hypotenuse was root 2. When the leg was 2, the hypotenuse was 2 root 2. When the leg was 3, the hypotenuse was 3 root 2. Notice these are all the same triangle. They're all going to have the same proportions. They just have different side measures. So if you wanted, you could figure out 4. You could do the Pythagorean theorem, or you can start to notice your pattern. You have 4 times 4, which is 16. 16 plus 16 is 32. Square root of 32 is not a perfect square, but the square root of 16 times 2, which is 4 root 2. Notice 4 and 4. Root 2. So that's kind of your relationship. If you always know this one, 1, 1, and root 2, you can basically figure out any triangle you want. So like if I said that you had a triangle that was 10 and 10, and this was, then you could do Pythagorean theorem, or you could just say, because you know your pattern, it has to be 10 root 2. It does get a wee bit more complicated. So what if it was the square root of 10 and the square root of 10? Well, you can follow the same pattern. This would be the square root of 10 times the square root of 2, which is equal to the square root of 20. And again, you are good math students, and you're always going to reduce your radicals. So the hypotenuse is actually 2 root 5. Now, here, comparing root 10 and 2 root 5, it might not seem as obvious that it's the relationship of 10 times the square root of 2, which is why sometimes I often recommend that instead of just multiplying by root 2, you actually set up a proportion. Setting up a proportion is also pretty handy when you're given the hypotenuse. So if I tell you that this time the hypotenuse is the square root of 10, let's say, so this is kind of like the reverse of the pink one above it, it might not necessarily be as obvious as what you do or what you should do. But if you keep this one in mind, that this triangle has to just be a bigger version of this triangle, then you can always set up a proportion. Let's say that that's x. X over 1 has to equal, because those two sides would match up in your proportion, has to equal root 10 over root 2. Again, keeping in mind that when you're setting up a proportion, you're staying consistent. So in this case, I put the purple triangle on top and the green triangle on bottom for both fractions. Now, if you wanted, you could cross multiply. But here it's almost unnecessary because this is x divided by 1. X divided by 1 is just x. And then here, since you have root 10 divided by root 2, that's root 5, because you're always allowed to divide roots. Let's do one that maybe isn't as simple. How about this time the hypotenuse is root 22. Again, you can still set up a proportion comparing this triangle to the smaller version of it, 1 root 2. This really just needs to be committed to your memory because you will use it in basically every single math class you take after this point. So if you set up a proportion, you have x over 1 equals root 22 over root 2. And this one is actually very similar to the previous one, where you have x over 1, so that's x, equals root 22 over 2, which is root 11. Not too bad, because it was divisible by 2. But let's do one that's not divisible by 2. How about we say that this one is, or technically it was divisible by root 2. Let's say that this one is root 13. Again, we can set up the proportion. Comparing our purple triangle to our green triangle, so we have x over 1 equals hypotenuse over hypotenuse, so root 13 over root 2. X over 1 is just x. Now, root 13 over root 2, you don't want to divide 13 by 2 and give me a decimal. You know that we do not express our answers as decimals. So here you would rationalize your denominator. So on the top of the fraction, you have root 13 times root 2, which is root 26. And then you have root 2 times root 2, which is root 4. And root 4 is 2. Now, if you could reduce this radical, you should, but you can't, because root 26 does not divide by a perfect square. Be careful. Remember, some of you are going to try to do it. You cannot divide root 26 by 2. You could divide two roots like we did here, but you cannot divide root 26 by plain old normal 2 because they're not the same type of number. Let's do one. How about this time the hypotenuse is just 20? Again, you're still comparing it to the normal 45, 45, 90, which is 1, 1, and root 2. So you have x over 1 equals 20 over root 2. Again, x over 1 is x. And we're still comparing hypotenuse to hypotenuse. 20 over root 2 does not reduce nicely. So what you need to do is, again, rationalize the denominator. So you multiply this by root 2, top and bottom, by root 2 over 2. So you have 20 root 2 over root 4. Keeping in mind that you can't actually multiply the 20 inside the root 2. You have to just tack it on the front. Root 4 is 2. Now, notice 20 over 2. 20 over 2 can reduce further. 20 divided by 2 is 10. And that's your answer, 10 root 2. Remember, this 2 here cannot reduce the 2 inside the radical. It can only reduce the numbers on the outside. Let's do one more together, and then I will let you loose to work on your assignment. Let's say that the hypotenuse here, how about as an odd number? How about 23? So again, we have 1, 1, and root 2. That's what we're comparing. So x over 1 equals 23 over root 2. You can't divide 23 by root 2. It does not work out nicely. So you have x equals 23 over root 2, because it's x divided by 1. So you have 23 over root 4, and then 23 root 2 over 2. Now, if you stop and notice for a minute, here, the 23 over 2, that does not reduce. And you do not want to say a decimal, so you would just say your answer is this, 23 root 2 over 2. I think that's enough for right now. Go ahead and start on your assignment.